So in previous lecture, we have already covered few topics related to this course, that is uh, introduction to the course, digital technique and microprocessor. Second topic we have covered is introduction to number system. Then third topic we covered is conversion between number systems. And this is the next topic from the curriculum point of view, that is BCD code. I am ST Kumbhare, lecturer, Electronics Engineering, Government Polytechnic, Gondia. So the topic for today's presentation are BCD code. We'll see what is BCD code first, then decimal to BCD conversion, BCD to decimal conversion, BCD addition and subtraction, and at the end, comparison between binary and BCD code. We have already covered binary code, so at the end, we can compare both binary and BCD. Now, outcome of today's presentation are identify BCD code. Means at the end of this presentation, you will be able to identify whether a given code or number is a BCD code or not. Then you will be able to represent given decimal number into its equivalent BCD code and vice versa. You will be able to perform addition, subtraction of two BCD numbers and differentiate between binary number and BCD code. Now BCD. BCD stands for binary coded decimal. What we do in this BCD code is we represent each decimal digit. Okay, each decimal digit. Now, which are the decimal digits? Starting from 0, 1, 2, up to 9. We have decimal digits. So, these decimal digits can be represented by their natural 4-bit binary equivalent. In previous presentations, we have seen how to represent these digits into equivalent binary, 4-bit binary equivalent. Why 4-bit binary equivalent? Because we can represent 0 to 7 with the help of 3 bits. But for 8 and 9, we have to use 4-bit binary code for representation. So what we do, we will represent all these digits starting from 0 to 9 with 4-bit binary equivalent. Okay, we'll use 4-bit binary equivalent. How to do that, we'll see in upcoming slides. Then decimal number has base 10. This thing we are aware about. It is also known as 8421 code. BCD code is also known as 8421 code. Why 8421 code? Because we are going to represent these decimal digits in 4-bit form. So if we, and again 4-bit binary form, so or BCD form. Whenever we say bit, it has a base 2. So starting from 2 raised to power 0, then 2 raised to power 1, then 2 raised to power 2, and then 2 raised to power 3. I have written this much only because I want to represent each digit in 4-bit code. So that's why I have written 4 times. Now 2 raised to power 0 is 1, 2 raised to power 1 is 2, 2 raised to power 2 is 4, and 2 raised to power 3 is 8. That's why it is called as 8421 code. Got it? Next. It is also known as weighted code. Basically, codes are differentiated in two forms or two types. One is weighted code and another is unweighted code. So this is a weighted code. Why weighted code? Because after representation of these digits in its binary equivalent, those binary equivalents will have weights like this 8, 4, 2, 1. Hence it is called as weighted code. Now next, this is the representation for each decimal digit in its equivalent 4-bit binary code, which is also known as BCD. So 0 is represented with 4 times 0. 1 is represented with 0001. 2 is represented with 0010. Now how to do that? That we have already seen previously. So 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, which is nothing but 8, 4, 2, and 1. So starting from 0, after each digit you have to change the bit. So 0, then 1, then again 0, then 1, and so on you can write. Look here, 0, 1, 0, 1, 0, 1, 0, 1. Now for next, here it is 2. So after two bits, you can change the bit. So two zeros, then two ones, then two zeros, two ones. Look over here, 0, 0, 2 times, 1, 1, 2 times, 2 times 0, 2 times 1, 2 times 0, and so on. Here it is 4. So we have to write down 4 times 0. And then we have to change the bit. And the next bit is 4 times 1. Look over here. 4 times 0, 4 times 1. Then we have changed the bit 0, 0. Since it is 8 over here, we have to write down 8 times 0 and then 8 times 1. So 8 times 0 and then 8 times 1. But since we want only 10 digits, so 8 times 0, then 2 times 1. But it's like this, we can write down the binary equivalent for given decimal digits. No need to remember. Don't try to remember. Try to understand. Okay. Now the next. So 0 to 9. Now if you see, there we are using 4-bit combination for representation of each decimal digits. If we are using 4-bit combination, we can have 2 raised to power 4, that is 16 different combinations. We can have 16 different combinations. We have used only 10 combinations. So now there are 6 more combinations available, that is for 1, that is 1011, sorry, 1010, then 1011, 1100, then 1101, next is 1110, and last one is 1111. Now these 6 combinations are left. So these 6 combinations are known as invalid BCD. These are known as invalid BCD. Okay, these are valid BCD code, but these are invalid BCD code. Why these are called as invalid BCD code? Because binary coded decimal. We are coding this decimal in binary form, and that is called BCD. In decimal, we have only 10 digits. After 10 digits, we don't have any digits in decimal. So the 66 remaining 6 combinations are not valid for decimal digits. That's why these are called as invalid BCD codes. So you should keep in mind, up to 1001 you have valid BCD code, and after that you have invalid BCD code. I hope you got this difference. Next, decimal to BCD conversion and vice versa. Just now we have seen the conversion from decimal to BCD in this slide. If you have 0, for 0 you have to represent 4 times 0. For 1 you have to represent 3 times 0 and 1. Like this, for each digit, you have decimal digit, you have to write down its equivalent BCD code in 4-bit form. So suppose I give you a number like 23, and if I ask you to write down its equivalent BCD code, What you will do, we will segregate these digits 2 and 3. So 2 and then 3. For 2, whatever BCD code we have, that we have to mention. You can find it from this table. So for 2 it is 0010, 0, 0, 0, 1, 0. For 3 it is 0, 0, 1, 1. No need to remember. I have already told you how to look. 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3. That is 8, 4, 2, 1. I want 2. So I'll make 2 as 1. Okay. I'll make this as 1 and remaining as 0. Got it? So 0, 0, 1, 0 for 2. For 3, if I want for 3, this 2 I will make 1, this 1 I will make 1, remaining as 0. So I can write down 0, 0, 1, 1. And for 23 you have to club all this. So 0, 0, 1, 0, 0, 1, 0, 0, 1, 1. So this is the BCD code for 23. Now the BCD code for a decimal number above 9, like this 23, or any number else other than 0 to 9. If we make a if we form a BCD code for the decimal number which is above 9, then this is known as, this one is known as fact BCD. Okay, this is known as fact BCD. Now you may feel that handwriting is not good. That's fine, because since I'm operating on computer, it's a bit difficult to write by with the help of mouse. So bear with me. So you have to keep in mind this terminology, packed BCD. If you write down a BCD code for a digital number or decimal number greater than 9, then this is called as packed BCD, because you are packing the different BCD codes. Okay. Next. So I hope all of you got this decimal to BCD conversion and BCD to decimal conversion. I we can take, okay, decimal to BCD conversion. Just now we are seeing, we will see the BCD to decimal conversion. How to do it? Let's clean up the board. Okay. Suppose the given number okay, now we'll see, go for BCD to decimal conversion. This conversion we'll see. Suppose the given number is 1, 0, 1, 0, 0, 1. If this is the number given, what we'll do, we'll start from the right hand side of or LSB. This is the LSB. Okay, we'll start from LSB and we'll start clubbing 4 bits. So we have clubbed this. Now again, you have to club the remaining 4 bits. But since there are only 2 bits, what you have to do, what you can do, you can add zeros before this. Okay, and after adding zeros, you have to write down its equivalent decimal digit. So 1001 is for 9 and 0010 is for 2. So the decimal equivalent for this BCD code 101001 is 29. Okay. Suppose if anyone gives you a number like 1011, Then can convert this into decimal digits or decimals because 1011 is a invalid BCD. That's why this is not a valid BCD. So since this is invalid BCD code, cannot convert into decimals. I hope all of you got this. Let's go to the next one. BCD addition. Okay, before going to this, I would like all of you to mark your attendance. So I'm going to share attendance sheet with all of you. All of you can see the link in chat and then I'm posting the link into the chat. Fill it in 5 minutes. Post your attendance in 5 minutes. Within that, if you have any difficulty or doubts, you can all of you fill the attendance sheet. I will give you 5 minutes. Click on the link and fill the attendance sheet. If any one of you have any doubt, you can ask. You can check out if your attendance is marked on or not on the screen. Fill the attendance sheet fast. If you have any doubts, you can ask. Someone not filled the attendance yet. Okay, fine. I will close the attendance sheet now. Okay, I hope all of you have completed the attendance. Fine. So we'll continue the session now. BCD addition. Now, all of you, please look at this topic. This is important one. How to do the BCD addition. Again, all of us know that 6 plus 3 is 9. Now, if I want to do BCD addition, how to do it? First, you have to represent the 6 in BCD form. So, I want 6 in BCD form. That can be written as 0, 1, 1, 0. And 3 can be represented as 0, 0, 1, 1. Now I can add both. So 0 plus 1 is 1. 1 plus 1 is 0. And there will be carry over here. Okay? Carry over. Then again 1 plus 1 is 3. And there will be carry over here. and then 1 plus 0, 1 plus 0, 1, 1. And if you observe this 1001 is the BCD code for 9. So like this we can do the BCD addition. We can do the same thing for this 6 plus 8. In decimal, we know 6 plus 8 is 1, 4. Then how to do the, now this is in decimal addition, but how to do it in BCD addition? So we have to write down 6 in BCD code, that can be written as 0, 1, 1, 0. 8 can be written as 1, 0, 0, 0. This is the BCD code for 6 and 8. Now we have to do the addition. 0 plus 0 is 0. 1 plus 0 is 1. 1 plus 0 is 1. And 0 plus 1 is 1. Now, if you observe this, this is not valid BCD because we have seen previously that 1, 0, 0, 1 is the highest BCD code for 9. After this, we don't have valid BCD. So this is invalid BCD. Then how to convert this invalid BCD code into valid BCD code? What we have to do, we have to add 6 into this number. So 6 is represented with 0, 1, 1, 0. Why 6 only? Why not other number? The reason is simple. We have 6 invalid BCD codes. That's why we have to add 6 into the number. So that will give us valid BCD code. Now, if we do the addition, 0 plus 0, 0, 1 plus 1 is 0, and there will be a carry. So, there will be one carry over here. If we add this, what will get? 1 plus 1 is 0, plus 1 is 1, and carry 1. Okay? There will be a carry over here. Again, 1 plus 1 is 0, and there will be a carry over here. Okay? There will be a carry over. This 1 will come over here. This 1 will come over here. Now, we have to start from LSB and we have to plug 4 bits. So, what we will get? Okay? 0, 1, 0, 0. This is the BCD code for 4 decimal. And since this is only 1, we can append some zeros over here. Okay? 1, 2, and 3. 3 zeros over here, and that will give us a number, decimal digit 0001 is 1. So now we can find 14 is the actual. So like this, you can perform BCD addition. I hope this is clear to all of you. Now next, let's take another example of BCD addition. 24 plus 1. I hope all of you can give me the answer. 4 plus 8 is 12. So 2, then carry 1. 2 plus 1 plus 1, that is 4. So the answer is 42. Now how to do in BCD? So 24 can be represented with backed BCD. So 2 is represented with 0, 0, 1, 0. And 4 is represented with 0, 1, 0, 0. Similarly, we have to represent 1. 1 can be represented with 0, 0, 0, 1, and 8 can be represented with 1, 0, 0, 0. Now we can do the addition. So this is for 24 and this is for 8. Now we can do the addition. So 0 plus 0 is 0. 0 plus 0 is 0. 1 plus 0 is 1. 0 plus 1 is 1.
0 plus, okay. Now, if you observe, what you will see is this. 0 plus 1 is 1. 1 plus 0 is 1 plus 0 is 1. This is 0 and this one is 0. Now if you look, this 4-digit BCD code is invalid one. So what we have to do? We have to add the 6 into this. So 0, 1, 1, 0. We have to perform addition. After addition, what you will get? 0 plus 0 is 0. Why 6? That we have already discussed. Because we have 6 invalid BCD codes. That's why you have to add 6. Then 0 plus 1 is 1. 1 plus 1 is 0. And there is a carryover. Okay? 1 carryover. Then 1 plus 1 is 0. Again, there is a carryover. Okay? Now, 1 plus 1 is 0. Then again, there will be carryover here. 1 plus 1 is 0. And then again, there will be carryover over here. 1 plus 0 is 1. And this is 0. Now, if you pull up 4 bits, you pull up 4 bits, this is this 4 and this 4. What you will get? 0 0 1 0 is 2 and 0 1 0 0 is, so you got the result. This is correct. So like this, you have to perform the addition. Similarly, we can perform addition of 48 and 50. How to do it? Is 48. So this 48 can be represented in this equivalent BCD code 4. So 0, 1, 0, 0, 8, 1, 0, 0, 0. Similarly, 58, 5, 0, 1, 0, 1, 8, 1, 0, 0, 0. And then we can add. So after addition, what we will get? 0 plus 0 is 0. 0 plus 0 is 0. 0 plus 0 is 0. 1 plus 0 is 1 plus 1 is 0. And there will be carry over here. Right? Then 1 plus 1 is 0. Then there will be a carry over here. There will be carry over here. 1 plus 0 plus 0 is what? 1. Right? 1 plus 0 plus 0 is 1. 1 plus 1 is 0. And there will be carry over here. Then 1 plus 0 plus 0 is 1. Right? So all of you are able to do this calculation. After doing this, you have to see whether this is valid BCD or not. Now 0000 is a valid BCD for 0. But 1010 is not a valid BCD. So what you will do in this form, in this case, you have to, what you have to do? Okay, you have to carry forward this valid BCD. So if we carry forward this valid BCD, we'll get 0 0. Okay, sorry, 1 minute. There is a correction. You have to add, since this is invalid BCD code, you have to, since carry is generated from it. Now, one more condition you have to do. From this highest bit from a nipple, carry is generated over here. Right? Since carry is generated over here, this becomes invalid BCD. And you have to add 0, 1, 1, 0 to this. This thing you have to keep in mind. What I said just now. If, okay, here we added, this is a nipple, 4 bit is a nipple, and we have added this nipple. So after addition, what we observe, there is a carry generated over here. Since carry is generated, this becomes invalid BC. Okay. Now you have to add 6 in this invalid BCD also. 0, 1, 1, 0. So after addition, you will get a number. 0 plus 0 is 0. 0 plus 1 is 1. 0 plus 1 is 1. 0 plus 0 is 0. Okay. Now this is 0 plus 0 is 0. Now this 1 is okay. 1, 0, 1, 0. We'll go step by step. We have first checked this, and now the result is invalid basic. 0, 1, 1, 0 is a valid basic. Now we'll check this. Again, 1, 0, 1, 0 is an invalid basic. So we have to add 6 into this number. So 0, 1, 1, 0. And this will come as it is 0, 1, 1, 0. After addition, 0 plus 0 is 0. 1 plus 1 is 0. And there is a carry over. 1 plus 0 plus 1, that is 0. And there is a carry over. 1 plus 1 is 0. And there will be carry. So this carry will come over. Now you have to again club 4 bits at a time. And after clubbing, what you get? This is 4 bit, this is another 4 bit, and this is another. So we'll add 3 zeros over here. What you will get? 0, 1, 1, 0 is 6, 0, 0, 0, 0 is 0, and 0, 0, 0, 1 is 1. So the answer is 106. Let's do the decimalization. What will get? 8 plus 8 is 16, so 6, carry is 1. 1 plus 4 plus 5 is 10, so 0 and 6. 9 is equal to 106. This is equal to this. So like this you can perform the question. I hope all of you got the what we did. We first perform the addition. After addition, if we observe a carry generated from this lower nipple, then the answer is invalid BCD. So we will add 6 over here. If carry is not generated, we'll just check the number. If it is beyond 1001, we'll add again 6. But if it is below 1001, then we will not add 6. After addition of this, again we'll check the result. If it is below 9, that is 1001, we'll keep it as it is. Then we'll see the next method. So this 10010 is again invalid BCD. So we'll add 6 into this and we'll see the. So like this, we can perform the addition. Next, that is BCD subtraction. Now BCD, in order to do this BCD subtraction, we have to use ninth complement or 10th complement. There are two ways. How to find out ninth and 10th complement? Just I will tell you that, and then we'll go to the actual subtraction. Suppose I have a decimal digit, let us say 1. So its BCD code will be 0, 0, 0, 1. And if I want to find out its ninth complement, what I have to do, I have to subtract this from 9. Okay. Ninth complement means I have to subtract even number from 9. So the answer is 8. And then its representation is 100. So the ninth complement of this number is this. Sorry, 1000. The ninth complement of 0001 is 100. The basic concept is, if you want to find out ninth complement, how to subtract that given number from the given digit from the number. Okay, let's take some example. 8 minus 2. I want to do the subtraction. If I do it directly, I will get 6 as the answer. So what I will do, I will write down BCD code for 8, and it is 1 0 0 0. This is for 8. Similarly, I will write down for 2, that is 0 0 1 0, and I will perform addition. Okay, even though I am saying subtraction, what we will do, we will perform addition. We will not perform subtraction. In 0 minus 0 is 0. Okay, then 0 minus 1. Sorry, wait. There is small correction over here. What we'll do, we will, before addition, first we need to find out the ninth complement of this two. Since we are going for subtraction, let's erase this. Okay, I want to do the subtraction. So what I will do, I will subtract. Instead of split subtraction, first I will find ninth complement of this. So ninth complement of this is 2. Ninth complement of 2 is what? 9 minus 2, 7. Then I will add this 2. Okay. So 8 plus 7 is nothing but what? Okay. 8 plus 7 is nothing but 15. Now if you observe, 15 is not the digit, right? So what I will do, I will add this 1 to 5, and then I will get 5 plus 1 is 6. So the answer is 6. Correct? All of you got this or not? Basically, let's take this as example. Here I want to subtract 9 minus 5. So what I will do, I will find its 9 complement. 5 is 9 complement. So 9 minus 5 is 4. Then what I will do, I will add 9 with the 9's complement of 5. That is 4. So after addition, 9 plus 4 is 30. Okay. Since it is beyond 9, what we will do? We will add this 1 carry to this. So what we will get? 3 plus 1. Okay, this is 3 plus 1. Will give us 4. And if you observe, 9 minus 5 is, okay, answer is, this is basic. I hope all of you got this. Let's take another example. 4 minus 8. That is reverse of that. How to do it? If I do this, what I will get? 4 minus 8 is minus 4 directly. But we'll do with the nines complement. So 4 minus 8. Nines complement of 8 is what? Nines complement of 8 is 9 minus 8, 1. Now what I will do? I will add this 4 plus 1. So what I will get? I will get 5. Right? I will get 5. But since carry is not generated, okay, since carry is not generated, I have to find out nines complement of this 5 also. So nines complement of this 5 is 9 minus 5 is 4. And since we have found the nines complement of the result, it will be yes, the answer is similar thing we'll do with this. Let's take this example. 79 minus 26. So if we do the direct subtraction, what we will get? We will get result as 9 minus 6 is 3, 7 minus 2 is 5. Let's check what happens in this way. So I will, what I will do, I will find out the nines complement of this 26. So nines complement of this 26, how to find out? 99 minus 26. That will give me n minus 6, 3, 9 minus 2, 7. So basically I have to add 79 with 73. This addition I have to. What is the basic step? First find out the nines complement of this and then add two things. First one. So 79 can be represented in binary ABCD code as 7, that is 0, 1, 1 and 1. This is 7. 9 is represented by 1, 0, 0, 1. Now 7 is represented with 0, 1, 1, 1 and 3 is represented with 0, 0, 1. Then we'll perform the addition. Now if you perform the addition, 1 plus 1 is 0. There will be carry 1. Carry will be generated. Then 1 plus 1 is 0 and carry will be generated. Right? 1 plus 1 is 0 and carry will be generated. Then 1 plus 0 is 1. So next 1 plus 0 is 1. No carry generated. Then 1 plus 1 is 0. Okay, and there will be a carry generated over here. One carry. Next, we will do another addition. So what we get? 1 plus 1 is 0 plus 1 is 1. And carry will be generated over here. Carry is generated over here. I'm changing the color so that it is visible to segregate. Then 1 plus 1 is 0 plus 1, 1. And carry will be generated. And the answer is 1 over here. Right? Then 1 plus 0 is 1 plus 0 is 1. So the answer is 1. Now, what we have to do? We have to see if this is valid BCD or not. Now, if you observe, what you will say, this is not a valid BCD. So we will add, let's say 6 into this number. So 0, 1, 1, and then we'll perform the addition. So after addition, what we will get? 0 plus 1, 0 plus 0, 0, 0 plus 1, 1, 1 plus 1, 0. There will be a carry over here. Then 1 plus 1, 0. And the carry will be generated. Got it? Now, okay, we'll perform this addition. So what will get? 0 plus 1, 1, 1, okay, 1 as it is, 1 as it is, 1 as it is. Now, this is not a valid BCD. This is not a valid BCD. So, since this is not a valid BCD, again we will add 6 into this number. Okay, so 0, 1, 1, 0. And we'll keep this as it is. So 0, 0, 1, 0, 0, 1, 0. And then we have to add this. 1 plus 0 is 1. 1 plus 1 is 0. And there will be a carry over here. 1 plus 1 is 1. And there will be a carry over here. 1 plus 1 is 0. And there will be carry over. Now, this one carry will be added to this. And you will get the result as 1 plus 0 is 1, 1 as it is, 0, 0, then 1, 0, 1, 0. So the answer is 0, 1, 0, 1 is 5 and 0, 0, 1, 1 is 2, which is correct. Yes. So like this, you can find out the BCD subtraction. What we have to do first, we have to find out the ninth complement of the second number. Then we have to add that into the first number, and we have to follow the similar procedure as we did in addition, BCD addition. Let's go to the next slide. Comparison between binary BCD. So BCD is less efficient than binary because it requires more number of bits for good. Simple. Let's take example. I want to represent 12. Okay, decimal digit in binary. In binary, it can be represented with 1, 1, 0, 0. But if I want to represent this decimal number in BCD, I have to represent it. I have to represent as 1 will be represented as 0, 0, 0, 1, and 2 is represented as 0, 0, 1, 0. So overall, I need 5 bits in BCD. This is in BCD. This is in binary. Okay. So in binary we need only 4 bits, but in BCD we need at least 5 bits for transmission. So that's why it is less efficient. More number of bits needs to be transmitted in BCD. Than- okay. Next, BCD and addition and subtraction is complex. Just no gaps. Every time we have to check some conditions. Then we have to add 6 if invalid BCD is observed at the additional result. Okay, so it becomes difficult for BCD addition and subtraction, and it is complex method. Next, conversion between BCD to decimal and decimal to BCD is easy. Okay, that this is the only advantage in this decimal BCD code, because you have to take each digit and you have to represent it with 4-bit binary. So it becomes easy. Now, this is the end of this topic. This is one of these I have made for all of you. I will make it available to all of you so that you will be able to check what you have, whether you have understood correctly. So that this is the reference I use, modern digital reference by RPJ. So these are the pages, and this is also one of the tools. From these pages you can check out. And this is a link I have referred from Google. Thank you all for this time from my side. If you have any queries, you can please unmute yourself and ask if you have any queries. Any queries? Any one of you?